Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to all my beloved students. This time we will learn how to do um, exercise related to the radiation, specifically spectral transmissivity. The cover glass on a flat plate collector has a low ion content, and its spectral transmissivity may be approximately by the following distribution. So this is the vertical axis showing the transmissivity, and the horizontal axis representing the wavelength in micrometer. So the question, what is the total transmissivity of the glass cover to solar radiation? To solve this problem, we need to do one of the assumption. Spectral distribution of the solar radiation is proportional to that of black body emission at 5800 Kelvin. Okay, so from the question we know that this lambda 1 is equal to 0.3 micrometer, and the lambda 2 somewhere over here is 2.5 micrometer. Okay guys, so this is the general equation related to transmissivity, which is G equal to the solar emission, and we do the assumption that it emits as a black body with the temperature of 5800 Kelvin, knowing that the solar irradiance with the emissive power are proportional constant, which is we can cancel it by the numerator and the numerator, and yet we express the transmissivity in this form, which is the transmissivity emissive power at the 5800 Kelvin divided by the emissive power of the black body at 5800 Kelvin. So we can solve this problem by using the integration approach based on the information from the question. Transmissivity 0.9, this one, and then is the range of the calculation of the integration from 0.3 to the 2.5 micrometer, and then the emissive power and the temperature at 5800 Kelvin, divided by the total emissivity black body at 5800 Kelvin. Or we can also solve this problem by using this radiation function, which is 0.9 from 2 or 0 until lambda 2, 0 until lambda 2, and then minus the 0 until lambda 1, which is over here. So by using this radiation function, we need to determine this function for f0 to lambda 2, and also f from 0 to lambda 1. Given the lambda 1 0.3 micrometer, lambda 1 temperature, we multiply 5800, then we obtain 1740 micrometer Kelvin, and we refer to the black body radiation function, and unfortunately the range stated in the table not exactly the same, so we need to do the interpolation to obtain the radiation function of 1740, which is 0.0335. And then same goes to the second approach by using the different wavelength, which is lambda 2 2.5 micrometer with the same temperature 5800 Kelvin, and we get the answer 14,500 micrometer Kelvin, and also do not stated directly in the table for the radiation function, so we need to do the interpolation as well, and we get 0.9664. Yet we insert all this information, transmissivity 0.9, the radiation function to the lambda 2 is the 0.9664, and then the function to the lambda 1 0.0335. So we get the final answer 0.85. So guys, this is your own exercise you can do during your free time. Okay, so what is the total transmissivity of the cover class to solar radiation? With the same question, so just change the figure or the data red in color, which is the transmissivity on vertical axis is 0.8, and so also change the value of the lambda of wavelength, which is this one 0.5, and the lambda 2 or wavelength 2 is 3.5 micrometer. So do not get worried. So also provide the final answer for you guys to refurbish. Based on my calculation, so managed to get 0.59, and you may consider the plus minus of 0.05 due to the decimal accuracy. But then if you find out this answer is not matched with yours, which is might be my calculation incorrect, then you may put in the comment so that we can try to discuss later which one give us the correct answer. Okay, maybe on my side typo or wrong calculation or whatever due to the wrong calculation. So that guys, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you.